All right, before we get into replication and division, let's talk a little bit about cells themselves. There are basically two types of organisms in this planet. There are eukaryotes and prokaryotes. And eukaryotes and prokaryotes differ in one main way, and that is that prokaryotes have a free-flowing nucleoid, which means that they have no nuclear envelope or no nucleus. The DNA material within the cell is allowed to flow freely and throughout the cell. Prokaryotes are also the original organisms of this planet. They were the first organisms ever, and they came around from what we can understand right now about 3.7 billion years ago. That's what this BYA means right in here, billion years ago. And eukaryotes are a little bit more complicated than prokaryotes. They do have a nuclear membranes, which means that they do have a nucleus of the cell. They also have a lot more complicated cellular structures. They have different what we call little tiny organs in the cells or organelles. There's a lot more of them. Eukaryotes first appear on our planet around 1.5 billion years ago. Now, there are a lot of organelles. I'm not going to go over all of them. I am going to concentrate on one right now called mitochondria. Mitochondria has an interesting story. Mitochondria is an organelle that's responsible for producing energy in the cell. And there's two things that are interesting about mitochondria. One is that it's only passed around matrilineally. That means it's only inherited through the mother. What I mean by it's only passed down matrilineally is that its DNA is only passed down matrilineally. And the interesting thing about its DNA is that it has a completely separate DNA than the actual nucleus of a cell. Why is this? Well, that's the part that's interesting about mitochondria. We believe that mitochondria at one time used to be its own separate organism and lived really, really close to maybe some prokaryotes. And as those prokaryotes evolved to become eukaryotes, mitochondria slowly comes inside the cell and they have this symbiotic relationship where mitochondria provides energy for the cell and the cell provides food for mitochondria. So we believe billions of years ago, mitochondria might have actually been its own separate organism and had finally got basically adopted by the cell. All right, so let's look at eukaryotes, which is what you and I are. Our cells, every cell in our body has a nucleus, so we fall underneath this category. Now, eukaryotes, the cells in our bodies can be further classified into two main genres. One is called somatic cells, which is every cell in your body that has a full set of chromosomes. And that's, remember, 23 from your mom, 23 from your dad. This 23 from your mom, 23 from your dad is called a diploid cell, which has 46 chromosomes. The other type of cell in your body is called a gamete cell or a sex cell. We call this a haploid cell because it only has half of the amount of chromosomes uh, that the rest of your body does, and this is 23. So it's not 23 from your mom, 23 from your dad. All right, so we're going to look at somatic cells and gamete cells. And in the next part, we're going to look at somatic cell division as well as gamete or sex cell division because these cells in your body constantly need to divide. They need to multiply and divide because, well, first, as you become mature, as you're a child and grow up, you need cell division in order to be able to grow. And as you slowly grow and you mature as an adult and are no longer growing, you need cell division in order to be able to maintain some tissues. You get a cut or a scrape, cell division helps bring that scrape closed. Actually, you're losing cells all the time. In order to be able to function, you need cell division. In order to be able to reproduce, you need cell division. So what we're going to look at in the next part is going to be this process of cell division, and we're going to look at mitosis and meiosis. Oh yeah, 8th grade biology is coming back.